addition, they have to pay 35% on any amount they have over $319,100. If Glenn paid $255,836 in federal income taxes in 2004, what was his taxable income for 2004? So I know I don't really need a table because it's just Glenn. If it was Glenn paid that much, and then Sally paid, twice as much as Glenn, and then their total salaries equaled something, that's usually the setup when I need to have a table. So instead, let's think about what's happening here. So let's say Glenn made $400,000. So if Glenn made $400,000, right off the top, he'd have to pay $92,592 in tax. Right off the top. Because it says anytime you make at least $319,000, you pay $92,000. All right, so if he made $400,000, he has to pay that $92,000 right off the top. In addition to that, he's going to have to pay 35% on any amount he made over $319,000. So if he made $400,000, you would subtract $319,100 from that total, and then multiply that by 0.35 to see what additional tax he owes. Does that make sense? All right. So Glenn paid $255,000 in federal income tax in 2004. So that means he made way more than $319,000. Because if you made anything less, you'd be paying less than $92,000. So let's talk about this. So first of all, he's going to have to pay $92,000. But let's just put X is his income. He is going to immediately have to pay $92,592.50. All right, if X is his income, then X minus that 319,100 would be the amount that he can get taxed again on. All right, so he paid $92,000 right off the top. This is his amount over that 309. So this is where he can get taxed again. So he originally taxed at $92,000. Plus, he's going to get taxed 35% of anything he made over $319,000. So that's going to be 0.35. That was our 35%. Times that X minus 319,100. That's going to be his amount over that $319,100. Well, it says that in total he paid some amount in tax, $255,000. So that's got to equal $255,836. So that would be the setup of that one. You're just trying to calculate how much tax he's paying according to his X income, and that's got to equal $255,000. Oh, you have this set up exactly like I do?
Yeah.
Expanded
0.35 times X minus 319,000.
Yeah, so you would end up with 0.35x minus 0.35 times 319,100. That'd be minus 111,685. And then I would subtract that 92,000-ish from that 250. So 255,836 minus the 92,592.5. We would have 16,320. Oh, that was way wrong. It was 163,243.5. Then I would add that 1,100 odd amounts to it. So it'd be plus 11,685. We'd have 0.35x equals 274,928.5. Then we divide both sides by 0.35. And we should come up with x equals 785,510. So 785. 510.
I guess they must have just had like a transportation.
Yep. Yep. As long as you have the setup, that's what's important. All right. Other questions? Brody.
For 21,
Mm-hmm.
I'm just confused on why it's an absolute value. Right.
Because, so at the end of the day on that one, we have the square root of a minus b squared.
Can it be B minus A?
It could be b minus a2. Yes. Yep. It could be either one of those. Now, when you have a square root, it canceling out a square, they just kind of cancel each other out, right? So you might think the answer is a minus b or b minus a, whatever order you have it. But that is not true. That is not true because let's look at if I had a negative in there. Let's say I had negative 7 squared. All right, order operation says I have to do inside to outside. So I would have to first square this. So this would actually have to be become a positive 49. Take the square root, it equals a positive 7. So this a minus b squared, whatever value that would be, squared would have to be positive because the square makes a positive, and then the square root gets rid of whatever got squared. So that means a minus b has to be positive. So that's why I put the absolute value bars around there. That you can't result in a negative 7. So if this turned out to be negative 7, just make sure you end up with a positive 7. Otherwise, you took a square root of a negative number, which is not possible.
Okay.
And that's why b minus a works also. Because a minus b and b minus a are going to be the exact same value as long as you put absolute value bars around it. Does that make more sense?
Yeah.
Cool. Other questions? Okay, let us talk about lines. Let us talk about lines today. Oh, and there's some nifty word problems at the end of this one. Yay, there you go. Yay. If anything, you should be happy because I'm throwing as many word problems as I can, which means when I write the test, you've seen all the word problems I have in my pocket. So most likely you're going to have seen the word problems that are on the test in your homeworks. They'll just be different values. All right, there's only so many different types of word problems that we do in this class. All right, that being said, let's talk about lines. If a, b, and c are real numbers, then the graph of the equation ax plus by equals c is a straight line provided that a and b are not both 0. One can be 0. X could be 0 or y could be 0. They both cannot be 0. Otherwise, you have 0 equals a number, which is not true. Or you have 0 equals 0, which is a point, I guess. We only have x values. Anywho, both can't be 0, but either one can be. In fact, if x is a 0, you're going to have a straight line. If y is a 0, you're going to have a straight line. You'll see that in your homework. All right. We're going to cover 2 ways to graph lines. The first way we're going to talk about is graphing lines using intercepts. Using our intercepts. These work well as long as our intercept isn't like 6,000 miles in the opposite direction. So, by setting x equal to 0 and solving for y, we can find the y-intercept. So letting x be 0 gets us our y-intercept. By letting y equal 0, we're going to get our x-intercept. So that's exactly what we're going to do. Whenever you're graphing using intercepts, what I do is I create a little table. And I set one of the sides as finding my x-intercept. And my other one's going to be finding my y-intercept. We only need 2 points to graph a line, so that's why we just need x-intercept, y-intercept. Well, to find the x-intercept, we're going to let our y equal 0. To find our y-intercept, we're going to let our x equal 0. Just plug them in and solve. So let y become 0, so we're going to have 2x minus 3 times 0 equals 9. Pro tip, most of the time you're not going to write the 3, you're just going to put 2x equals 9. Because that's going to cancel out. We're left with 2x equals 9. and x equals 9 over 2. Well, that's really just 4.5. This is like the only time I'll change fractions to decimals because it's a lot easier to picture it on our graph. All right, so that means we are going to graph the point 4.5, y, 0. All right, we go to our thing. We go x is 4.5, y is 0, and we have our x-intercept right there. That is our 4.5 comma 0. All right, y-intercept. Replace x with 0, so we would have 0 minus 3y. I'm going to write it all out just because it's your notes. So I have 2 times 0 minus 3y equals 9. That's going to give me negative 3y equals 9. That's going to give me y equals a negative 3. So where x is 0, y equals a negative 3. 0, negative 3. Our line goes through those 2 points. That is our line. Now, I know a lot of people love this slope-intercept, but honestly, x and y intercepts are really easy because you can do them in your head a lot of times. Like, I could picture my x canceling out, just dividing both sides by negative 3 and coming up with y equals a negative 3. So I can graph a lot of that in my head without having to put in a slope-intercept form, worrying about slope, counting up 2 over 3, up 2 over 3, making sure everything is perfect. 2 points, x-intercept, y-intercept, can be really quick on short problems like this. In fact, if you look at this one, just in my head, if I let x equal 0, y equals 40 is one of them. If I let y equals 0, I would add x to both sides. I'd have x equals 40 as well. I could do all that in my head without even making a table. But just for note's sake, we're going to go ahead and make our table. We're going to go x-intercept. Letter y equals 0. Y-intercept. Letter x equal 0. So if I let my y equal 0, we're going to have 0 equals 40 minus x, add x to both sides, and we'll have x equals 40. So this one would be the point 40, comma 0. If I let x equals 0, we're just going to have y equals 40 minus 0. Well, that's just 40. That would be point 0, 40. But you could have done that in your head. So we have 40, 0. That is my 40, 0. And we have 0, 40. Then we connect our 2 points as best I can with my tools. That's not even close. That's just failure. Let's just do that. Good enough. Good enough for government work. All right. That is graphing using intercepts. The next one we're going to talk about is using slope-intercept. Slope-intercept form. Who remembers slope-intercept form? Yep. Y equals mx plus b. What is the m? Yeah, it is slope. That is our slope, which is rise over 1. I always do change in y over change in x, which is the same thing as rise over run. Change in y is your up, down. Change in x is your left, right, which we affectionately call rise over run. This little delta always means change. Delta means change in math. Change in y over change in x. What is b? Liv.
Your y-intercept.
My y-intercept. And my y-intercept is wherever x equals 0. So this would actually be the point 0, b. So when we're doing slope-intercept form, we're always going to find our y-intercept first, and then we're going to decide how the slope affects that point. So we look at our graph. So I need to graph y equals negative 2 over 3x. Well, that's in slope-intercept form. So that tells me that this negative 2, make sure you do the whole negative 2, is my y-intercept. In other words, this is the point 0, negative 2. So we plot that point right there. That is my 0, negative 2. All right, this whole negative 2 over 3 is my slope. So your slope is negative 2 over 3. I always put the negative to the top. So with rise over run, if I have negative 2, rather than going up and over, because it's a negative 2, I'm going to go down and over. I always go to the right. I let the negative affect my up or down. So negative 2 over 3 would be down 2 over 1, 2, 3. So once again, I would go down 2, 1, 2, and over 3, 1, 2, 3, and my point would be right here. If you needed to make another point, you would just go the opposite direction. If I go down 2, right 3, the opposite direction would be up 2, left 3. So we could go in the opposite direction, which would be up 2, left 3. That could be really useful when you can't go up or down in a particular region because you have a graph that's drawn. Kind of weird. Let's just do this here. All right, so that's my line. Our next one isn't in slope-intercept form. Honestly, if I was solving for this one, I would find my intercepts. I wouldn't waste the time to put it in slope-intercept form. I would just find my x and y intercepts. But we are in the slope graphing using slope-intercept form, so we have to put it in slope-intercept form. So that means get your x to the other side. So we're going to have 2y equals 5x minus 4. Divide everything by 2. And we're going to have y equals 5 over 2x minus 2. 2 is my y-intercept, which means it is the point 0, negative 2. Again, bleh. But this time my slope is a positive 5 over 2. That means I'm going to go up 5, right 2, or down 5, left 2. Up 5, right 2, down 5, left 2. Down 5, left 2 really isn't going to work that well because I'm going to go off my graph. So let's instead go up 5, 1, 2, 3, 4, 5, and over 2, 1, 2. And that will be our next point. I think perhaps previously you had to have 3 points. 2 points make a line. So in this class, if you find 2 points and you're confident in them, just draw your line through those 2 points. I do want you to have arrows on both ends. That's important in math. Otherwise, you have a line segment. And I'm asking you to graph the entire line. It does not end. All right, so that is graphing using intercepts and using slope-intercept form. I like to think of these as they're different tools. You have a screwdriver and you have a hammer. You shouldn't use one all of the time. Like I said, a lot of us kind of gear towards using slope-intercept form because they're like, yeah, mx plus b equals y. Don't use it every single time. In fact, in this one, I would probably find my y and x intercepts just because I can almost do that in my head. Because to find my y-intercept, I let x equals 0. Well, that's just dividing both sides by 2. I have y equals negative 2. Boom. I replace that. I get rid of that. And my x-intercept would be negative 4 over negative 5, which would be 4/5. So I can just do that as well. So sometimes it's easier to use x and y-intercepts. Sometimes it's easier to use slope-intercept. Don't force yourself to use one particular thing over and over and over. All right, the next thing we have is using a graph to solve a particular equation. Now, it isn't the most useful item of solving equations. The only time you're going to see something like this is if you're provided a graph and you have to read it for answers. So most of the time I'm not going to make you graph it and solve it, but on the test I could give you a line and say solve for these equations without doing any work. So in this case, we're supposed to graph y equals 2x minus 6. Well, that is already in slope-intercept form, where our y-intercept is at negative 6. And our slope is 2. Remember, if your slope is 2, your m is really 2 over 1. It is up 2 over 1. Otherwise, you're just going 2, 2, 2. You have to move over. Otherwise, it's not really a slope. So we're going to go up 2 over 1, up 2 over 1. I'm going to do a bunch from up 2 over 1, up 2 over 1. I just want to make sure everything is set up because we're going to actually solve for specific points. So let's connect those. And we have that. All right, our first one is use the graph to solve the equation 2x minus 6. Well, if you look at this, if we look at our regular equation was 2x minus 6 equals y. The only thing that changed was y becoming a 0. So that means I'm looking at where is y equal to 0. Well, y is equal to 0 at, so let's go to our graph and figure out where y equals 0. Y equals 0 is up or down. Y equals 0 is right here. That's where my y value is 0. So y equals 0 at the point that x value is 3, 0. Once again, our x is 3, our y is 0, and so 2x minus 6 equals 0, where x equals 3. So the solution to this one is x equals 3 by just looking at the graph. Our next one's similar. 2x minus 6 is the exact same setup as our equation. 2x minus 6 equals y. So we're looking at where y equals negative 2. Well, y equals a negative 2. We go down to where y equals negative 2, which is right here. It leads us to that point, negative 2, 2. So y equals negative 2 at point 2, negative 2. So x just equals 2. All right, more than likely, your test question would look something like this one, where you don't have all your in-between values. You just got to figure out how to read it. We're supposed to find the solution by reading the graph. So it says our original equation was 5 over 6 times x plus 30 equals y. They're asking, what is my x value when I replace y with 0? So we're asking is, where is y equal to 0? Now you might think this is, once I do it, it should seem like an easy problem. I think something like 40% of people missed this on the test. They flipped a coin at which one of the two values was, so it was about 50-50, maybe a little better that some people actually had educated guesses on it. I'm asking, where is y 0? Your y value is your first or your second value. So if you pick this one, if you pick 0, 30, you're actually figuring out where y equals 30. That isn't what I'm asking. I'm asking for where is y equal to 0. So if we look at our 2 points, we have x, y here. We have x, y here. So where y equals 0 is right here. So your answer is actually going to be x equals a negative 36. Don't be the person that gets this wrong if I put it on again this year. I don't think I did last year. Last year I did. The year before I don't think I put one on because I thought it was too easy, but they showed me wrong last year. It was supposed to be an easy question and a whole bunch of people missed it, which means it was supposed to be just an easy 4 points, and a lot of people lost 4 points because they didn't know what was going on. Make sure you know how to do this. What I think happened was people thought it was too easy to even study, and then they didn't know how to do it on the test. All right, that is really all I have for you. I do want to talk about the homework really quick. It says sketch a graph of each linear equation. be sure to show the x and y intercepts. So I'm not telling you how to graph it, but if you graph it using slope-intercept, you still have to find your x-intercept. The other thing I want to talk about is the first word problem. I don't think I put a number on it. The first number on it where Jason drove his rig on Interstate 10. Why I'm bringing this up is I told you don't use two variables unless you absolutely have to in your charts. In this particular case, you're more than likely going to have to use two variables. All right, there's just no way to rewrite it in terms of x alone. So you'll most likely have to use two variables. It's a slightly harder problem because it looks like they almost don't give you enough information. They just barely give you information. They give you your average speed on one direction, and they give you your average speed that you want to have. And they also tell you you're halfway. They don't give you any miles. They don't give you any times. You have to put variables for all that stuff. All right, so it's a slightly harder problem. The one right after it is our classic painting a house work problem. So that one will hopefully be easier than the first one. So maybe do the easy one first and then focus on the hard one. All right, the homework shouldn't take you that long. That's why I put a really hard word problem on there. All right, guys, the rest of the time is yours. I am going to walk around. I'm going to check your homework that was